we were continuing with our review of the midterm, and we got up to problem 14. So let's take a look at that. Where are you? Oh, I know what the problem is. Here we go. Needed. The 14. So any questions with the midterm review up to this point? Okay, so we got to 15. We haven't done 15. Determine the slope and the y-intercept. Do we need to go over that one? No. We good? Okay. All right. 16. Determine the average rate of change. It's just, for this one, they just give you the, it's a linear equation, okay? They just give you now the average rate of change of a parabola, right? That's when you're going to need 2 points. But the average rate of change for a linear function is the same as the slope, okay? Because if you're given a parabola, okay, if you're given like a parabola and you're trying to find the average rate of change of 2 points, let's say between 1 and 3, okay? Well, basically, and if you have an equation x squared plus 2, let's say. Well, you're going to put it into the f of b minus f of a, right? Over b minus a, where b would be the 3 and a would be the 1, right? So basically, what you're trying to do is you're trying to find the slope to this line, because that's where your average rate of change is, right? And that's what this is. This is average rate of change, but average rate of change is slope between these 2 points. And so you're going to develop a linear equation, right? But when you have a linear equation and you're trying to find the average rate of change there, you're already, here we're trying to establish a slope for a linear equation, right? Between these 2 points to get the average rate of change. So you're trying to get the slope. Well, here, you already have a linear equation. So the slope of a linear equation is the same as the slope of the line. So the average rate of change is the slope of a linear equation.
So it's -2.
It's -2, yeah. Okay, so that's why there's a difference between when you have 2 points and in a nonlinear equation, right? You're trying to find the average rate of change of a nonlinear equation. That's when you need 2 points. But when you have a linear equation, you're not going to be given 2 points. They're just going to ask you what's the average rate of change, and you just say, okay, well, it's the slope, and that's it. You're done. Okay. Okay. All right. Now 17. Determine without graphing whether the given quadratic function has a maximum value, minimum value, and then find that value. Okay. Do we have any questions or this one? Okay. What you look at here, okay, this is f of x equals to x squared minus 6. Okay. X squared minus 6. So, with that, okay, you look to see which way is this going to open. It opens up, right, because it's positive, right? Opens up. So we know it's going to open up. So right there, that's going to tell you, are you going to have a minimum or a maximum? You're going to have a minimum, right? So we know it right away, this is a minimum, okay? And so, this shifted which way? This shifted, well, what's the difference between that? Yeah, it's down, good, down. So basically, so they tell you not to graph it, but I mean, I'm just showing you, okay, you know it's going to shift down, and you know that it opens up. So right now, we know that our minimum has to be what? -6. So our minimum is -6. Okay? And I believe that's all they asked for, it's just the minimum. Determine without graphing whether the quadratic function has a maximum or minimum, then find that value. So I don't believe they're asking for the location, just the what it is, just the minimum. Yeah, they just need the minimum. Okay. All right, any other questions there? Okay, number 18. Okay. Now this one, yeah, this one's going to open down, right? Now you can't tell by looking at it, but through transformation, with this one. So you have to use a different method. So you've got -12x squared minus 2x minus 6. So what do we have to do? What equation or what formula or what algorithm or whatever you want to call it? We know it opens down. So therefore, we know that is that a minimum or a maximum? Okay, we know that's going to be a maximum. But we don't know what that maximum is yet. So what equation do we use? So basically what we have to do is we have to find the vertex, right? Once we find the vertex, then we can find the maximum value. Mm-hmm. So what do we have to do first? Yeah, you got to use the axis of symmetry equation, right? -b over 2a, where a is, here's a, b, and c, right? ax squared plus bx plus c, where a is what? -12, b is -2. So we're going to put in here minus what? Minus 12. Minus a -12. Good. Because this minus is the minus for the equation, right? This minus is the minus for b. For the b. Over 2 times -2. So we got a lot of negatives going on, right? So we got, either you can cancel minus a negative, you can cancel a negative, 2 negatives this way or 2 negatives this way, it really doesn't matter. Okay, so we're going to end up with a negative, right? And I like to cancel when the numbers are small. So we can cancel 2 into 12, and that's what? 6. And then we can cancel 2 into 6, and that's what? Yeah. Yeah. You get negative 3. Okay. Now what do we do? Plug it back into our exits, right?
No, that's not. You plug it back in, you get 1, right?
Right. So our vertex is negative 3, but we don't know what the y coordinate is yet. So we plug it in, right? Okay. So we've got negative 12, and then open parentheses, negative 3, close it, and that's squared, and minus 2, parentheses, negative 3, close it, minus 6. Okay, just double checking here. Oh, wait a minute. There's a mistake here. This should be parentheses. Here we go. Just double check, make sure this is all right. And I got a negative 5 instead of a negative 2. Change that. Okay. And so we get a negative 108. Okay. So what is our maximum? So this basically negative 3, negative 108. So which one of these two numbers is our maximum value? Yeah, negative 108. Max negative 108. Let me double check this. Make sure this is right. Yeah. Okay. Any questions there? Well, this is negative 71 over 12. That doesn't make sense. That doesn't make right. It doesn't make right. Okay. Any other questions? All right. 19. Solve the inequality. Any questions with that? Basically, you solve it just like it was an equal sign, except for you're going to have. Let's go ahead and do one of them. Let's see. What? 19. All right. Yeah, I was looking to see which one would be the one you'd be more likely to ask for. Okay, we have x squared minus 2x minus 15, and that's less than or equal to 0. Okay, so first thing, when you're solving a quadratic, there's three ways to solve a quadratic. What are those 3 ways? Zero factor property, right? Where your factor, square root method, which we did that, and the quadratic formula. Okay? 3 ways. So factoring A lot of people don't like to factor, but factoring can be easier than using the quadratic formula if they're integers. Okay, so we want to see if we can factor first. And so our factors, we set our factors equal to 0. But we don't want to forget that this is less than or equal to, all right, because we've got to come back to this. So we put in our parentheses, we put in our x's, and we look at our C term, and we determine, are the same signs going to be the same or opposite inside the factors? They're what? When the C term is a negative, yeah, the signs are opposite. So one sign's a plus and the other side's a minus. It doesn't matter which one's plus, which one's minus. And we look at factors of our C term and our A term. Well, A is just 1, so, and you can't factor out a common factor, right, a GCF. So we just have to look at the last term. And you go 1, and you always start with 1 in the number, because sometimes, not always, I mean most of the times you won't have these two. But sometimes you do. So you have to consider all the factors. 1 and 15, and what are other factors of 15? 5 and 3. Or yeah, 5 and 3 or 3 and 5, right? And that's all. So either one of these pair of factors will give you 15. But only one pair of factors will give you the middle. So what pair of factors will give you the middle? 3 and 5, right? So if we put 5 here and 3 here, we've got to check it, right? Negative x times 3. You could use a full-blown FOIL, right? X times x is x squared, right? And x times 3 is a negative 3x. And 5 times x is plus 5x, and then 5 times negative 3 will give you negative 15. Well, either one of these two will give you negative 15, but only one of these will give you the middle. Well, negative 3 and a positive 5, that's a positive 2x, but we don't want a positive 2x, we want a negative 2x. So the number's right, but the signs are wrong. So what can we do? It's an easy way to fix that problem. Switch the signs, right? Make the minus sign a plus, make the plus sign a minus, double check it again. X times 3 is a positive 3x, negative 5 times x is negative 5x, and we get negative 2x, and now it checks. You got to check your factoring, okay? Because if your factoring's wrong, guess what? The solution is going to be wrong, okay? So you got to check your factor. Okay, once you do that, now what do we do? Good. Set each factor equal to 0. X minus 5 equals 0, x plus 3 equals 0. Subtract 5, or add 5, right? Plus 5. We get x equal to 5, and x equal to a negative 3. But that would be fine if this were an equal sign. But it's not an equal sign, it's an inequality sign. That means it's not just two numbers, it's going to be a range of two numbers. And these are known as what we call the boundaries. So within these boundaries, our solution is either going to be in between these two boundaries, or they're going to be outside. They're going to be in between the two boundaries, negative 3 and 5, or they're going to be outside. But we don't know which. So we use a test point, okay? And 0 is the easiest test point to use. Because with 0, you just put 0, 0, and whatever's left over is your answer, right? So we cut out the x and we put 0 in here, right? We substitute 0 in. So this is parentheses squared minus 2 times parentheses minus 15 less than or equal to 0. Okay, so all I did was I just cut out the x's and I substitute 0 in, right? 0, 0. Well, that goes to 0 and that goes to 0. So we have negative 15 is less than or equal to 0. Now, if that's true, then the solution, then 0 is a solution. And if 0 is a solution, then all the points in between are a solution. But if 0 is not a solution, then it's all points outside. So you could check, you could use one test point, and they recommend 3, but you can use one test point and get your answer. Well, is negative 15 less than 0? Is that true or false?
True.
That is true. So that means negative 15 is in our solution, is part of our solution. Or a negative, I mean not negative 15, that means 0. I'm sorry, 0. That means 0 is part of our solution. Okay, put a military 0 on there. Okay, so that means not only is 0 a solution, but all points in between are a solution. And because it's less than or equal to, is that an open parentheses or closed bracket? Closed bracket. Well, if one's a closed bracket, the other one's a closed bracket. So now you just use your number line to come up with your solution. So this will be a closed bracket to what? And what do we put here? Closed bracket, negative 3, 2, 5, closed bracket. And that's our solution. Okay? Questions there? So if you were to graph that, okay, you would have something like this, where all this underneath is less than 0, graphically. But you don't have to graph it. You can just determine the boundaries and use the number line, okay? But this is technically, so what you're looking at are the x values that are going to give you your graph, your profile, to be less than or y is 0. In other words, below the x-axis, right? Because this is your coordinate plane. But all you have to do is give the interval, right? The x values, or interval and interval notation. Okay? Boy, that's sometimes they ask for the set notation. What they guess for? Okay? Questions there. Okay, so we good with the last one, or you want to see that one too? We good? Okay. All right. So, what's that? Do we need to see 20? Let's go ahead and do 20. We'll do 20. Okay. So, 20, back up, is x squared plus 12x plus 35, and that's greater than 0. Okay? Okay, so what I want you to do is factor that. Okay? And while you're factoring, I'm going to go ahead and get attendance here real quick. All right, go ahead and do that. Okay, everybody checked. Okay, put in our x's, right? Our signs, this one's easy, they're both plus, right? So we're looking for factors of 35, which are 1 and 35, and what else? 5 and 7, right? And that's it. Okay, sometimes 5 is 35, right? So this is going to be 5, and this is going to be 7, right? And so we set our factors equal to 0. And solve, so we get x equal negative 5, and x equal to negative 7, right? Yeah, because you're solving for each factor, right? We set each factor equal to 0. Okay, so you've got to pay attention to that inequality sign, right? So we've got here negative 7 and negative 5. Well, we can still use 0 as a test point, because if 0 is a test point, then that's outside. If 1's outside, then they're both outside, right? They're either going to be in between negative 7 and negative 5, or they're going to be outside of negative 7 and negative 5. So if 1 is outside, if 0 is outside, and that's a solution, then the other one is also, okay? So they're always going to be either outside or in between these, what we call the boundaries. So you can just look at this, right? Put 0, 0, and we know that these cancel, right? They go to 0. So we ask ourselves, is 35 greater than 0? Is that true? Yeah, it is. That's true. So that means, what is that telling you? That 0 is part of the solution, right? Well, if 0 is part of the solution, all the points outside are part of the solution. On one side and the other. And so wherever there's an arrow, we put infinity in the negative direction, infinity in the positive direction. And so are these boundaries, are they going to be open parentheses or closed brackets? Open parentheses. Open parentheses at negative 7, open parentheses at negative 5. Okay, so now we're ready to write our solution. So what's our solution going to be? Negative infinity, and infinity is always what? Open or closed? Can we ever get to infinity? No. We can't, right? Infinity goes on forever. So infinity is always open. We can tend towards infinity, right? But we're never going to get to infinity. And so that'd be negative infinity to what? Negative 7. And that's open parentheses, right? And then we use U for union, to unite the two. And then what? Open at negative 5 to infinity, and infinity again is always open. And that's our answer. Okay? Questions there? All righty. All righty. So that is